We're going to use the unit circle, and we're going to use it with the Pythagorean theorem to help us find sine and cosine. What we know is that with a triangle, we have the Pythagorean theorem where a squared plus b squared equals c squared. Now what we're going to do is we're going to replace a with x, we're going to replace b with y, and we're going to replace c with r. Now we know that r is 1 with the unit circle, so that means that x squared plus y squared equals r squared. Now we talked about last time that our y squared is sine and our x squared is cosine. Now, when we square something with sine and cosine, all the trig ratios, we put the squared in between the trig ratio and the degree. So it's sine squared theta plus cosine squared theta equals 1. And that's what we're proving with the Pythagorean theorem. Now that brings us to two formulas. One is the formula to find sine, and the other one is to find cosine. When we're finding sine, what we're going to do is we're going to subtract the cosine. So what we get is sine squared theta is equal to 1 minus cosine squared theta. Now we have to get rid of the square. So what we do is we take the square root. And when we take the square root, we always have to remember there's a positive and a negative root. So that means that sine of theta is equal to plus or minus the square root of 1 minus cosine squared theta. Now that's our first formula. Our second one is solving for cosine. And that's going to be similar to sine. We're going to get the cosine by itself, so we're going to subtract the sine. So we get cosine squared theta is equal to 1 minus sine squared theta. In order to get rid of the square, what we're going to do is we're going to find the square root. And remember, when you have a square root, there's a positive root and a negative root. So we have cosine of theta is equal to plus or minus the square root of 1 minus sine squared theta. And those are the two formulas we're going to be working with. If we look at our first example, it tells us that we have sine is 0.766. It tells us that's in the quadrant from 0 to pi halves. And what we're doing is we're solving for cosine. So we're going to go cosine of theta equals plus or minus the square root of 1 minus 0.766 squared. We're going to plug that into our calculator, and what we get is 0.643. Now there's a problem. We're not sure if it's plus or if it's minus, and that's where the quadrant comes in. What we're going to do is we're going to figure out what quadrant it's in. We have 0, pi halves, pi, 3 pi over 2, and then when we go around again, it's 2 pi. This is in between 0 and pi halves, which would be the first quadrant. And if you remember from last time, we have the saying, all students take calculus. The all means that all the trig ratios are positive, so that means cosine is positive, and that is our answer. For letter B, what we're going to do is the same thing. We're solving for cosine. We're going to go cosine of theta is equal to plus or minus the square root 1 minus, we're going to plug in our value, and we get negative 0.644 squared. Now, one thing I'm going to point out, whenever you square something, it's always positive. So when we plug it into our calculator, what we get is 0.765. Now, once again, we have to decide, is it a positive root or a negative root? We have 0, pi halves, pi, 3 pi over 2, and then 2 pi. This is in between pi and 3 pi over 2. All students take calculus. Tangent is the only one that's positive. This is not tangent, so that means that it's negative. Now, if we're looking at our third one, it's a little bit different because we're solving for sine. We're going to go sine of theta equals plus or minus the square root of 1 minus, remember the negative goes inside the parentheses, when we square this, it's positive, and so what we get is sine of theta equals 0.109. Once again, we have to decide, is it positive or is it negative? We have pi halves and pi. Pi halves and pi would be the second quadrant. All students take calculus. Sine is positive, so that means that we have a positive answer right here.